Hello again. Chapter 6 talks a lot about parenteral, and if you remember what parenteral means, it's outside of the GI tract, but usually we use this term when we're talking about injections. But it's also for oral calculation. So basically, any medication that comes as a liquid, this works either way. And truth be told, it works pretty much with tablets too. But at this point, you've probably figured out how to do that calculation on your own. So we're not going to spend any time talking about tablets. But parenteral or oral calculations, we will. Now, you'll notice with some of these problems, the milliliters are spelled a little different. That's because I took these problems from a British website. So it's not that I don't know how to spell. It's just this is British English and not American English. So let's take a look at the first one. And if you meet anybody who's ever gone through our program, they will instantly know what you're talking about when you get through with this particular tutorial and with class, because it kind of has become a running joke. So the clients ordered 35 milligrams. Well, in your book and in some other places, that they call that desired. What do you desire? I say, what do you want? The doctor orders this. That's what you want. It doesn't matter, how you get it, but this is what you have to have. We can't change the doctor's orders. So what you want is 35 milligrams. What you got, which means if you go to the shelf, and this is where sometimes it's called quantity on hand or whatever. It's the same thing, is what do you got? If you go back to our lab and you go find this medication, how is it labeled? Because remember, some drugs can have several different strengths. So if it says, all right, 50 milligrams and 1 milliliter of liquid is available, that's what you got. So 35 milligrams is what you want. What you got is 50 milligrams. So what you want, what you got, and then how does it come? It comes in 1 milliliter. What you want, what you got, how does it come? What you want, what you got, how does it come? Okay, now some people try to skip this step because anything multiplied by 1 is still itself. The problem is going to be in the next problem, and you're going to see why it's important to, while you're practicing this, to make sure you've got this figured out. So the patient needs 35 milligrams of this drug. That's what we want. What we got is 50 times 1. So 0.7 milliliters is what's required for this dose. Now think about that for a second. If 50 milligrams is in 1 milliliter, right? Well, if we pull back a little bit, and I encourage you to kind of think big picture sometimes, because you get too tied up into figuring out the number. But 50 milligrams in 1 milliliter. So it stands to reason that there's 25 milligrams in half a milliliter, because that's half of that, right? Well, what we want is 35. So it's going to be more than half, but less than 1. And that's exactly the problem that we've got. Now, if you really like the ratio proportion formula that we talked about, you can use that. So if there's 50 milligrams in 1 milliliter, and there is, because it tells us that. Remember, for that ratio proportion problem, you have to have 3 pieces of the puzzle. If there's 50 milligrams in 1 milliliter, then there's 35 milligrams in X milliliters. So this is the same way of doing this problem. This is ratio proportion. This is called the formula method. And honestly, this is an extra step, and most people prefer this. What you want, what you got, how does it come? Okay, and next semester when we start doing IVs, you're really going to see how this works, because you'll get the dose and you won't know how to finish the problem till you actually go pick the bottle off the shelf. Okay, so let's do the next one. A client is ordered 50 milligrams. So what you want? 50 milligrams. Okay, and this is an oral medication. 125 milligrams in 5 milliliters is available. So what you want is 50. What you got, 125 times 5. See where that is different from this. So if you forget this step, and it's okay to skip it if it's times 1, because 0.7 times 1 is still 0.7. It's not going to change. But if you get in a habit of skipping that step, then you're going to have a problem like this where it says it's in 5 milliliters of liquid, and that changes the whole problem. So just be careful with that. And this is one of those problems where people who are really good at math and can do it really quickly, they miss these problems because they don't slow down enough to look at the fact that it's not in 1 milliliter. So what we want is 50 divided by 125. That's what we've got. Now, if we stop right there, the answer is 0.4, but that's not the correct answer because we've got to multiply it by 5. So 0.4 times 5 is 2 milliliters. Okay?
Yep.
All right, let's do the next one. Client is ordered 30 milligrams of furosemide IV. And notice, most of these problems, we don't really care what the drug is. So 30 milligrams is what we want. 10 milligrams in 1 milliliter is available. So 30 milligrams is what we want. 10 milligrams is what we got. Times 1. Sorry about that. I tried to do times 3. So what you want, what you got, how does it come? Now, your brain should know that 30 divided by 10 is 3. But be careful. We're going to run into another problem in a minute, and I'll show you what I mean. But your brain wants to make things easy. So it wants to divide 10 into 30 and make it 3. But sometimes it goes the opposite way, and that'll be incorrect. So give me a minute, we'll get to that problem. Client has ordered 20 milligrams of haloperidol, 50 milligrams in 1 milliliter is available. So what you want is 20, what you got is 50 times 1. 20 divided by 50, 0.4 times 1 is still 0.4. And again, think about that as far as if 50 milligrams in 1 milliliter, then there's 25 milligrams in half a milliliter if you cut it in half, right? So we just want 20, not 25, but so it's a little bit less than half. All right, let's look at the next one. 50 milligrams of aminophylline is ordered. That's what you want. What you got is 250 milligrams in 10 milliliters. See how that makes a big difference between 1. So if you don't do it by 10, you're going to get the wrong answer. So 50 divided by 250 times 10 is 2 milliliters. Okay, let's do a few more. Okay, client is ordered 75 milligrams. That's what we want. Available is 50 milligrams in 1 milliliter. That's what we got. 75. Make sure you can see that. 75 divided by 50 times 1, 1.5. Okay, now here's the problem I told you that you'd have to be careful with. So, client is ordered 25 milligrams. 25 is what you got. 50 milligrams in 5 milliliters is available. 50 times 5. Now, really super smart people who are good at math tend to do this really fast, and they think that, well, 25 goes into 50, so that's 2. It's not. 25 is half of 50. And this is a very common mistake when people get rolling on, because your brain wants to do the easiest thing, which means putting 25 into 50 twice. But that's not what it is. So if we actually, make sure we do our math, 25 divided by 50 is half. It's not 2. So 25 divided by 50 times 5 equals 2.5. Okay, and the final one, 5 milligrams is ordered. 40 milligrams in 2 milliliters is what we have. So 5 divided by 40 times 2, 0.25. And again, if you struggle with this, think about it kind of holistically. 40 milligrams in 2 milliliters. Well, that means there's 20 milligrams in 1 milliliter because you cut it in half. We don't even need that much. We just need 5. So the number is going to be very small. The other part of this chapter deals with powders for reconstitution. And I'm going to explain in class to you the concept of powder volume. And that's not something I really want to try to explain here, because I really need you in front of me to make that click for you. And sometimes people still have a difficult time with that, and that takes even more time next semester to get a really good handle on it. I don't know why it is, but everybody struggles with this. I've talked to other instructors and they struggle with it, so struggle with teaching it. So we're just going to look at the very basics here. So the order we have here is 250 milligrams. Okay, that's what we want. That doesn't change. What you want. Now, the what you got part is a little different. So the rest of the problem says we have ampicillin 1 gram, and we're reconstituting it with 1.5 milliliters of water. So it starts off as a powder. We need to add this to the powder to make it a liquid so we can work with it. So the one thing you have to realize is this is milligrams, this is grams. Something's got to change. One of the two has to change. So, and it really doesn't matter which one. So whichever, but to me, we started off with milligrams, so I would change this to milligrams. So 1 gram, remember, is 1,000 milligrams. So what you want, what you got, and well, how does it come? Well, it doesn't tell us any different right now, so it's going to have to be 1.5. That's the only number we have for volume, right? So 250 divided by 1,000 times 1.5. Let's do our math. 250 divided by 1,000 times 1.5. 0.375. Now, at this point, we've started to work a little bit with syringes. And if you want to take an empty syringe home with no needle, you can do that to practice. But you're not going to measure this amount exactly. It's going to be just impossible to get this amount. So we're going, and again, how to round up and when to round up and to what place value. Usually it's to the 10th. So we're going to round this up to 0.4. There are cases when maybe 0.37 is what we need, but we'd have to use a very small syringe to get that. And that would be, you would see that with a few drugs, like adrenaline can be that small of an amount, or a very small person. So if you worked at Children's Hospital, you might go to the 100th place, but for the most part, we're okay with going to the 10th. Okay, so let's look at the next problem. Doctor orders 250 milligrams of Ancef. Okay, that's what you want. We can't change that. So 250. Now there's a lot of stuff in this problem that we don't need. So it says the medication reads 1 gram of Ancef in powder form. Reconstitute by adding 2.5 milliliters of sterile water for injection, for a total volume of 3 milliliters. Okay, here's the easy part. Get down to this. Because at the end of the day, when it says the concentration will yield 330 milligrams per milliliter, go with that number. It's much easier to do to try to than trying to figure out the rest of it. So 330 times 1. And I'll show you in class a couple ways where you could use all this information if you wanted to. But once you see the words to yield or will result in, I would go with that. So 250 divided by 330 times 1. And again, we've got a weird number, so we would do 0.8. Okay? All right, here's another one. Doctor orders 125 milligrams of Solu-Medrol. 125 is what we want. Medication is supplied in powder form and reads 0.5 grams per vial. Reconstitute according to the directions so that each 8 milliliter will contain 0.5 grams of Solu-Medrol. Okay, so let's look at what we really need out of this. Okay, what we want is 125. What we got is 0.5 grams. Again, we have to switch it like we did up here. So 0.5 grams is 500 milligrams. And we added 8 each 8 milliliters will have 500 milligrams. So times 8. 125 divided by 500 times 8 equals 2. All right. A physician has ordered 25 milligrams. That's what we want. Add 2 milliliters of diluent to yield. So I'd focus right in on that. 100 milligrams per 2 milliliters. Okay, 25 divided by 100 times 2, 0.5. Okay, here's a problem that looks like a big problem with lots of stuff in it, but let's see if we can zoom in on what we really need. Physician prescribed. Okay, that's what we want, 500. You ought to be pretty good at that part by now. Of Cefzox IM every 12 hours. The medication is available as a powder in a 2-gram vial. Reconstitute with 6 milliliters of sterile water for injection and shake well. Fluid volume will equal 7.4 milliliters. We need none of that. What we need is solution concentration will provide 270 milligrams per milliliter. So 500 divided by 270 times 1.9. We'll round up. 1.9. Okay. That gets us through another lesson, and we'll talk about percentages and dilutions on the next tutorial. Bye.